But it's certainly real. It's using an energy field and what we probably would say is electrogravitic. And whether it is a purely extraterrestrial origin or a mix of an ancient human extraterrestrial development.
A new revelation from Dr. Stephen Greer has sent shockwaves through the UFO and science communities. The Buga Sphere, a metallic orb found in Colombia, appears to be thousands of years older than Egypt's pyramids. Early studies suggest it was crafted with technology beyond known human capabilities. Researchers now race to uncover what's inside: ancient intelligence, forgotten technology, or something extraterrestrial. Greer says the findings could challenge the very foundations of human history. Buga Sphere's discovery. March 2025. The skies above Buga, Colombia were calm, until they weren't. Locals watched, stunned, as a small metallic sphere darted across the sky in sharp zigzagging movements, controlled, intelligent, not a drone or a rock. It didn't crash. It landed. In a quiet field on the outskirts of town, it sat half buried in the dirt. The site was undisturbed. No signs of fire, heat stress, or structural impact. Just a smooth, seamless orb that looked like it had been dropped there by something or someone that didn't care if it was seen. When villagers approached it, they expected to find parts or panels, maybe bolts or screws. Instead, the surface looked like brushed steel, flawless, with faint patterns that resembled ancient symbols. But here's where things got weird. Nothing held it together. It simply existed, complete, seamless, whole. Once the sphere was retrieved and scanned, things got even stranger. Inside, researchers found 3 perfectly nested metal shells. Between them, gaps of air. At the very center, smaller spheres, 9 to 18 of them, perfectly round, seemingly floating inside. Word spread fast. A video surfaced online within hours. The internet dubbed it the Buga Sphere. That's when the theories exploded. Some said it was alien tech. Others believed it was a lost relic from an advanced ancient civilization, evidence that our past was far more complex than we thought. Then came Dr. Stephen Greer's team. They took a small sample from the surface and sent it to the University of Georgia's radiocarbon lab, one of the most respected in the US. The goal? To date the material. And that's when the real chaos began. The results came back with a jaw-dropping number: 12,560 years old. Let that sink in. That's older than the pyramids, older than any known metalworking on Earth. We're talking Ice Age. Headlines ran wild. Reddit lit up. People asked, could this prove there was advanced technology on Earth thousands of years before history says there should have been? But here's the twist, and it's a big one. The material that got tested? It wasn't the metal. It was organic residue, fossilized microshells called foraminifera, likely sediment that stuck to the sphere while it was buried in the ground. And radiocarbon dating? That only works on organic material, not metal. So what did the lab actually date? Not the sphere, but the ancient dirt on it. Imagine finding a brand new phone covered in antique dust. Would you say the phone is old because the dust is? Of course not. Once that mistake was uncovered, scientists backed off the 12,560-year claim. The age result didn't prove anything about the object itself. It just made it clear that the sphere had been underground for a while. Maybe a very long while, but no one could say how long. And that's when the conversation shifted from what is it to how do we prove what it is. Forget the theories. This is about facts, not noise. First step? A full elemental analysis, breaking the metal down to its atomic ingredients. Every alloy has a signature. If it doesn't match anything we know, like titanium, aluminum, or any industrial mix, then we've got a real anomaly. Next, scientists want to look at isotope ratios. Think of isotopes like the DNA of an element. Every planet, asteroid, even individual mine has its own unique isotope profile. If the sphere's metal doesn't match Earth's natural isotope patterns, that could mean it wasn't made here. Then comes microscopic imaging, scanning the sphere's layers and surfaces to figure out how it was built. Or maybe grown. No seams or welds. If modern tech can't replicate that structure, then maybe it wasn't built by modern hands. And what about those small spheres inside? Using ultra-precise 3D scans, researchers plan to digitally map every microlayer and every internal object. Once that data is fed into AI pattern detection software, we may discover if the microspheres form a deliberate structure, like data storage or a geometric language. Imagine a kind of three-dimensional hard drive, with information encoded in position and space instead of just zeros and ones. Some have even suggested checking for electromagnetic activity, the kind machines give off even when inactive. Low-frequency hums, heat fluctuations, or subtle vibrations. Machines whisper. Nature doesn't. So, what do we really know right now? We know a strange, metallic sphere landed in Buga. We know it's unlike anything we've built, with a structure modern engineers can't explain. And we know that early dating results were based on ancient sediment, not the sphere itself. But we also know that the mystery is far from over. Because this object, whatever it is, has forced the scientific community to lean in, not look away. It's no longer about proving aliens or ancient civilizations. It's about the process, the hunt for truth, the possibility that something strange might teach us something real. Whether the Buga Sphere turns out to be a hoax, a breakthrough, or just a really weird hunk of metal, this investigation is already pushing the boundaries of what we know and how we search for answers. So the next time someone tells you all the big discoveries have already been made, just remind them of one thing. Somewhere out there, in a Colombian lab, a smooth, silent sphere is still holding on to its secrets, and we're just getting started. Discovery is only the beginning. Now comes the hard part, figuring out what this thing is, piece by piece, test by test. Proposed tests and analyses. After the initial buzz died down, the viral clips, the alien theories, the what-if speculation, something surprising happened with the Buga Sphere. Scientists started paying attention, and not the fringe ones either. Serious researchers, engineers, physicists, metallurgists, the kind of minds that don't get caught up in hype unless there's something measurable to work with. They ask the only question that really matters in cases like this. What is it, really? No guesses, no stories, just data. Hard, measurable, repeatable data. Because at the end of the day, mystery is just another word for an unanswered question. And science lives for those. Researchers broke the mystery down into three main possibilities. The first was the most sensational. The sphere might be extraterrestrial, made somewhere beyond Earth. If that was true, the metal itself would tell the story. Every world, every asteroid, every mine has a unique chemical and isotopic fingerprint. If the material didn't match anything found on Earth, that would raise serious questions. The second possibility was just as intriguing. Maybe it was built by humans a long time ago. Not modern humans with factories and satellites, but by an ancient civilization we've forgotten, or maybe never even knew existed. The construction could hold the clues. Ancient tools leave distinct marks. Ancient methods leave behind unique structural patterns in metal. But the sphere had none of that. No seams, no welds, no joints. It looked fused, like it wasn't built at all, but rather grown or formed in a way we don't currently understand. Then there was the third possibility, the most grounded one. Maybe it's a modern artifact, some kind of military tech, aerospace component, or experimental material that fell out of a classified project and into a Colombian field. If that's the case, there should be signs, known alloys, manufacturing patterns, or traceable parts. Each possibility leads to different types of evidence, and each test scientists proposed was designed to answer one piece of the puzzle. No wild speculation, just one methodical check after another. The first step, elemental analysis. This test breaks the object down into its base ingredients. What kind of metal is it made from? Is it steel, titanium, a rare alloy, or something else entirely? Every alloy has a chemical recipe, and if the Buga Sphere's recipe doesn't match anything known in aerospace, industrial, or military databases, then the mystery deepens. After that, researchers move to isotope ratio testing. Think of isotopes like the DNA of elements. Every source of raw material on Earth, from mountain ranges to ocean floors, has a unique isotopic balance. If the sphere's isotopes don't match Earth's, then either it came from outside our planet, or from a source so rare or ancient that it's no longer part of modern supply chains. That's not definitive proof of alien origin, but it would be a massive red flag. Next comes microstructure analysis. Scientists plan to examine the internal grain of the metal at a microscopic level. Why? Because how something cools, shapes, or bonds leaves a record, like tree rings in a cross-section. Was it forged, cast, laser fused? Every process leaves a trace. If the structure shows no signs of any known joining method, it might mean the layers weren't assembled. They were somehow formed as a single piece. Then there's the matter of what's inside. Early scans already revealed something odd. Nested within the sphere were multiple smaller spheres, microspheres, perfectly round, floating within the inner core. Researchers want to use high-resolution 3D CT scanning to get a complete digital model of the interior. The goal is to map out every layer, every sphere, every contour inside the object without damaging it. Once they have that model, they plan to feed the data into AI-based pattern recognition software. It's a wild idea, but not unfounded. What if those smaller spheres aren't just randomly placed? What if they form a deliberate pattern? A kind of physical code, encoded in geometry. Just like computers store data using binary, this could be a storage system using spatial relationships. Angles, distances, and alignment could form a message, or even a machine logic system that we don't yet understand. Now here's a big question. Could the Buga Sphere still be active? Machines, even when they're turned off, can emit electromagnetic fields, vibrations, or thermal signatures. Nature doesn't do that, but tech does. So scientists want to perform full electromagnetic scans, sweeping the object across a broad range of frequencies to see if it's emitting anything, any hums, pulses, or repeating signals. They'll also use thermal imaging to see if the sphere changes temperature over time. If it warms and cools in cycles, that might suggest internal systems are still functioning, or were recently active. Another test involves exposing the sphere to controlled magnetic fields. If it reacts in a structured way, meaning it aligns, pulses, or responds predictably, that could point to internal mechanisms or energy systems designed to interact with magnetism. None of these tests are dangerous. They're non-invasive, entirely safe, and capable of revealing a massive amount of information without so much as scratching the surface. But it doesn't stop in the lab. Researchers also plan to investigate the field in Buga, where the sphere was found. Locals reported something strange. patches of dead grass that didn't grow back, and soil that felt dry and lifeless even in rainy weather. Scientists want to collect soil samples from the landing zone and compare them with control samples nearby. If they find molecular changes, radiation, or dehydration effects, it could suggest that the sphere released energy on impact, or at some point before or after landing. There's also interest in studying the surface of the object itself. Using high magnification imaging, scientists hope to identify microabrasions, tiny scratches or grooves that could indicate movement. If these marks are aligned in a consistent direction, it could prove the sphere didn't just fall, it maneuvered, controlled flight, maybe even intelligent navigation. Then comes another angle, tracking where the sphere has been. Every region on Earth has its own unique mix of pollen, minerals, and microscopic particles. If the sphere's surface carries traces from multiple far-flung regions, especially those inconsistent with its discovery site, it could suggest it traveled across great distances, maybe even across borders or atmospheres. To top it off, scientists want to use geophone sensors, devices that detect subtle vibrations in the ground. The idea is simple. If the sphere gives off rhythmic internal vibrations, even at extremely low levels, it could be a sign of movement or activity happening inside. Inactive objects don't hum. Machines do. All of these tests are rooted in real, validated science. None rely on belief. And each one brings us a step closer to an answer. The best part? The researchers involved are pushing for full transparency. That means chain of custody documentation, blind testing protocols, and public data releases. They want the scans, readings, and reports uploaded to platforms anyone can access. The idea is that truth, no matter how strange, should never be hidden behind closed doors. So what happens if the results are shocking? If the materials don't match anything known? If the isotope signatures point off-world? If the internal geometry reveals a pattern too perfect to be accidental? Then we'll be looking at one of the most important discoveries of our time. But even if the sphere turns out to be a misunderstood piece of Earth-based technology, the investigation still matters. Every test refines our methods. Every question pushes science forward. Whether it's a breakthrough in materials, science, data storage, or electromagnetic systems, we're bound to learn something new. But tests mean nothing without trust. To make sure the results hold up, scientists are doing something rare in cases like this, putting everything out in the open. Data transparency and scientific integrity. When a story like the Buga Sphere hits the world, one thing becomes clear fast. People want the truth. Not rumors, not mystery, but real answers backed by facts. And to get there, scientists have to play by one simple rule. Be completely transparent. That means every step of the investigation must be open for anyone to see, from the moment the sample is collected to the moment the final report is released. It starts with something called chain of custody, a record that tracks who handled the sphere, when, and where. Each transfer is documented, signed, and sealed. That way, no one can later say the evidence was swapped or tampered with. It's the same system used in forensic labs and criminal cases, because when the evidence is clean, the results can be trusted. The next step is to eliminate bias through blind testing. Here's how that works. Scientists send small coded samples to different labs, but no one knows which sample comes from where. The technicians just run their tests and report their data. When the results come back, the codes are revealed. If the numbers match across labs, everyone knows the results are real, not influenced by personal opinions or expectations. But that's not enough. To keep everything open, the data itself needs to be shared with the world. Researchers plan to upload every scan, measurement, and report to public databases like Zenodo or Figshare. Anyone, from university students to independent experts, can download the files and study them for themselves. That way, discovery becomes a team effort, not a secret club. To make the process even clearer, the team wants to set up a public tracker, a live online record showing every test being done, who's doing it, and when results are expected. No waiting for dramatic reveals or hidden conclusions, just science happening in real time. And finally, every major test should be repeated by independent laboratories that don't communicate with each other. Replication is the heart of good science. When two or more labs reach the same conclusion, it turns speculation into evidence. This open approach doesn't just protect the truth, it builds trust. Because when everyone can see the process, the story of the Buga Sphere isn't just about mystery anymore. It becomes a model for how real discovery should be done, in plain sight, for everyone. As the data piles up, only a few explanations remain on the table. Some are wild, some are reasonable. All of them matter. Possible outcomes. As the tests begin and the data starts to roll in, scientists say there are only 3 possible ways this story could end. 3 paths that could explain what the Buga Sphere really is. Each path tells a very different story, but all of them lead to something worth knowing. Path A is the most extraordinary. The idea that this sphere was engineered by an intelligent maker, possibly not from Earth. If the metal shows isotope ratios that don't match anything found on our planet, or if the internal structure follows mathematical patterns too precise to be natural, it would mean someone, or something, built it. That would be the biggest discovery in human history. Proof that we're not alone. But the scientists are careful here. They know that extraordinary claims need extraordinary evidence. So they're looking for clear signs of design, not just strange coincidences. Then there's Path B, which is just as fascinating, but a little closer to home. This theory says the sphere might be human-made, but by someone far ahead of their time, or by a group whose work was hidden or forgotten. Maybe it's part of an old experiment, a secret project, or technology that never made it into the public eye. If that turns out to be true, it would still be groundbreaking. The techniques used to build a seamless, layered metal sphere could push modern manufacturing years ahead. We'd be learning from our own past, rediscovering something we somehow lost. And finally, there's Path C, the most down-to-earth possibility. Maybe the sphere isn't a machine at all. Maybe it's a natural object that only looks unusual, or a modern artifact misinterpreted through hype and excitement. Even then, the investigation still has real value. Every test, every scan, every open report adds to science's playbook. It improves how we study strange findings, how we confirm results, and how we separate truth from noise. So no matter which path the evidence points to, alien, ancient, or ordinary, something important will come from it. The mystery isn't just about proving what the sphere is, it's about how we search for truth. In the end, that's the real discovery. Not what we find, but how we find it. With possibilities this big, alien, ancient, or revolutionary, it was only a matter of time before the world's most advanced space agency stepped in. And when they did, they didn't come quietly. NASA takes notice. It didn't take long for the Buga Sphere to hit the radar of the biggest space agency on Earth, NASA. At first, their response was predictable: silence. No public comment or any press release. But behind the scenes, things were moving. Within weeks of the discovery, researchers from NASA's Jet Propulsion Laboratory, JPL, quietly requested access to the raw scan data collected by Colombian and university-based teams. On paper, the request was routine, collaborative review of anomalous material data. But insiders say it was anything but routine. The Buga Sphere had sparked internal debate at NASA, especially among engineers who specialize in non-terrestrial materials and propulsion systems. What caught their attention? Two things. First, the structure. NASA's materials scientists were particularly interested in the sphere's seamless layering and nested geometry. If the object wasn't machined, cast, or welded, then how was it formed? Some theorized a type of additive manufacturing far beyond current aerospace capabilities, possibly even molecular assembly. That's the kind of tech NASA dreams of using on deep space missions. Second, the maneuverability. Eyewitness reports of the sphere's controlled descent, zigzagging, shifting angles without visible propulsion, mirrored what NASA has privately tracked in classified UAP data. It didn't match conventional flight mechanics. If the Buga Sphere really landed on its own, then whatever guided it wasn't using jet thrust, rotors, or anything we understand. That made it a potential game changer. NASA's involvement escalated when a formal inquiry was made to the Colombian government, specifically a request for international cooperative analysis. The idea: allow U.S. labs to conduct non-invasive studies on the object under a shared data agreement. On the surface, it looked like science diplomacy, but others saw it differently: a grab for control. Colombian officials declined, for now, citing sovereignty, cultural protection laws, and ongoing domestic research efforts. Still, rumors circulated that NASA-linked advisors had offered equipment, grants, and even satellite data in exchange for deeper involvement. Publicly, NASA maintains its usual stance, open to collaboration, but not currently involved in any official investigation. Privately, documents leaked in August 2025 show that a NASA task group, informally labeled Project Hermes, was created specifically to monitor and evaluate developments related to the Buga Sphere and any similar future anomalies. Hermes stands for High Energy Reconnaissance of Metallic Extraterrestrial Structures. The group includes aerospace engineers, AI analysts, physicists, and 2 former members of the now-defunct UAP task force. Their mission is clear. If this object came from space, or from someone who mastered it, it has implications for planetary defense, advanced propulsion, and future exploration. That's the NASA angle. Curiosity, yes, but also strategy. Because, in their world, any anomaly is a potential breakthrough or a threat. And with the Buga Sphere still locked away in a lab in South America, one thing is certain: NASA's watching. But no matter what the sphere turns out to be, one thing is already clear: the impact of this discovery could reach far beyond the lab. Broader implications. If the Buga Sphere turns out to be real, truly engineered, and not just a strange lump of metal, then what's hidden inside it could change everything we know about technology. Because if this object is a machine, even a small one, its design could open doors that scientists have only dreamed about. Let's start with energy, the thing that powers our entire world. Right now, everything from your phone to an airplane depends on large, heavy batteries or constant fuel. But imagine if this sphere holds a system that stores energy far more efficiently than anything we've ever built. Compact, stable, and powerful. That kind of technology could power homes without the need for power grids. It could let hospitals in remote areas run equipment without fuel. Relief teams could carry portable power sources into disaster zones and keep entire camps running. Even spacecraft could travel farther, faster, and cleaner. Next, Think about flight. How things move through air. Witnesses saw the sphere zigzag across the sky before landing, changing direction sharply, without wings or visible propulsion. If that's true, it suggests some kind of inertial control, a way to move through space smoothly, maybe by manipulating gravity or energy fields instead of pushing against air. Right now, we rely on engines and wings, but this object, if it really maneuvered, could hold clues to a whole new form of motion. Imagine aircraft that never shake in turbulence, drones that hover silently, or spacecraft that don't need rocket fuel. Even if none of that turns out to be alien, the engineering alone could revolutionize industries on Earth. The sphere's structure, multiple metal layers fused together with no seams or welds, is something current factories can't easily reproduce. That means new methods of metal bonding and forming could be hiding inside it. If scientists can understand how those layers connect without melting or joining, it could lead to stronger, lighter materials. Airplanes, cars, and buildings could all be built with less weight and more strength. Medical implants could last longer. Machines could handle higher pressures and temperatures. And that's only the start. New alloys, metals mixed in unique ways, often lead to major breakthroughs. The materials inside the sphere might have properties we've never seen, maybe extreme durability, self-healing surfaces, or resistance to heat and corrosion. Even one of those traits could change how we build technology on Earth. But here's what's important. These benefits don't depend on proving it's from another world. The truth is, science wins either way. If it's alien, we gain knowledge from beyond Earth. If it's human-made, we rediscover techniques that can move us forward right now. Either outcome pushes technology ahead. And that's the real reason this investigation matters. The Buga Sphere isn't just an object. It's a mirror reflecting how far we've come, and how far we still could go. Alien or ancient, the Buga Sphere is rewriting the rules. Like, comment, share, and subscribe for more discoveries that push the boundaries of what we think is possible.